Welcome to Lesson 3 in the Mr. Circuit Lab on digital logic gates. In this lesson, you will learn about the AND digital logic gate. An AND digital logic gate can have as many inputs as needed. The one we will explain has two inputs, and therefore there are four possible combinations of input states as shown in the AND truth table. The first possible input combination is a 0 on input A and a 0 on input B. The second is a 0 and a 1. The third is a 1 and a 0. And the fourth is a 1 and a 1. Remember that a 0 means a false and a 1 means a true. On an AND digital logic gate with only two inputs, both inputs have to be a true for the output to be a true. Otherwise, the output is false. The general rule for an AND gate is stated as follows. The output of an AND digital logic gate is true only if all of the inputs are true. Here is a practical example of a digital AND gate. Input A. It is sunny outside. Input B, I have time. Output Q, I will go to the beach. Since with a two-input AND gate, both inputs have to be true for the output to be true, it means I will go to the beach only if both conditions are true. That is to say, it is sunny outside and I have the time. Here is the symbol for a two-input AND digital logic gate. Look at it carefully. The symbol has a flat bottom and top with a curved right side. And it has two input lines on the left and one output line on the right. Okay, let's talk about building an electronic AND logic gate. Here's the schematic for an electronic AND digital logic gate. In this Mr. Circuit Digital Logic Gate Lab, as part of your training, you will construct this circuit on a solderless breadboard. Let me explain the circuit. You will notice that this circuit is more complicated, as it has two transistors, one LED, four resistors, a 9-volt battery, and two normally open push-button switches. As in all digital logic gate circuits, when the LED is lit up, it means there's a true on the output. Let's talk about the transistors. Remember that when a transistor is forward biased, it means that it has the correct voltages on its pins to allow electron current to flow through it. Here we have two transistors. When you press switch S1, you forward bias transistor Q1. And when you press switch S2, you forward bias transistor Q2. In this AND digital logic gate circuit, the engineer designed it so that the LED will only light up when you forward bias both transistors at the same time. To do that, you have to press S1 and S2 simultaneously. When both switches are pressed, the path for the current is from the negative of the battery through the LED, then through transistor Q2 and Q1, then through resistor R1 and back to the positive of the battery. If you do not press any switch, or if you only press one switch at a time, the LED will not light up, which indicates a false on the output of the circuit. So as you can see from this explanation, this circuit works like an AND digital logic gate. Only when both inputs are true will the output be true. That is to say, only when you put a voltage on the input of both transistors at the same time will the LED light up. Now that you understand how the electronic circuit for an AND digital logic gate works, you are ready to build one as part of your training, following the step-by-step instructions in Lesson 3 booklet. The world needs lots of people who know and understand these concepts and that can work with digital logic gates. Continue with the rest of the lessons in this lab so you can earn your certificate of electronics training that you can display and add to your resume. If you need to buy this Mr. Circuit 3 lab, you can purchase it at www.mrcircuittechnology.com. We hope you're enjoying this lab and will want to learn more electronics. Thank you from all of us here at the Mr. Circuit Technology Company.